Hey everyone, ever wonder how AI could become a superhero for cybersecurity? Today, we're diving into a groundbreaking study that's redefining how machine learning models acquire expertise by teaching them through mentorship. Let's unpack how this works, why it's a game changer, and what it means for the future of digital defense. Here's the challenge. Training AI to detect and neutralize cyber threats is like teaching a novice to navigate a minefield without a map. It's slow, error-prone, and resource-intensive. But what if we gave these models a head start? This research explores using a pre-trained AI as a mentor, guiding a newer model to avoid common mistakes and accelerate its learning curve. The goal? To create cybersecurity systems that adapt faster, smarter, and with fewer errors. Think of it like learning to play chess. A beginner might take hours to realize that moving the queen too early exposes it to capture. But a grandmaster's advice, prioritize piece development over premature queen movement, cuts through the noise. Similarly, this study uses a teacher AI to share its accumulated knowledge, helping a student model avoid pitfalls and focus on high-impact strategies. It's not just about speed, it's about learning the right lessons from the start. The researchers tested 4 distinct techniques to implement this mentorship. 1. Reward shaping. The teacher AI assigns additional rewards for actions aligned with its strategies, effectively creating a feedback loop that reinforces optimal behavior. 2. Action masking. The teacher blocks risky or suboptimal actions in real time, akin to a coach intervening during a critical moment. 3. Auxiliary loss. The student model's training objective includes a secondary loss function derived from the teacher's outputs, forcing it to internalize the mentor's decision-making framework. 4. Feature Space Modification. The teacher injects domain-specific insights into the student's input data, acting as a form of guided feature engineering. In a simulated cyber environment called CybORG, all 4 methods significantly accelerated the student AI's learning, particularly in the early stages. But the results weren't uniform. For instance, auxiliary loss proved remarkably effective, enabling the student model to match the teacher's performance in just 20 training iterations, 5 times faster than unguided learning. Conversely, reward shaping had minimal impact, while feature space modification occasionally confused the model by overloading it with extraneous information. These findings highlight the importance of method selection based on the specific demands of the task. Cyber threats are evolving at an unprecedented pace, outstripping traditional defense mechanisms. By enabling AI to learn from mentors, we're not just improving efficiency, we're building systems capable of real-time adaptation. Imagine an AI that doesn't just react to attacks but predicts them, leveraging the collective experience of its predecessors. However, this approach hinges on the mentor's expertise. If the teacher AI isn't robust, the student inherits its flaws. The upside. This research demonstrates that we can build on existing knowledge rather than starting from scratch, drastically reducing the time and computational resources required. Picture this, a cybersecurity AI that doesn't just defend your data, but anticipates threats with the wisdom of a seasoned expert. This isn't science fiction, it's the future of machine learning. As AI systems grow better at absorbing mentorship, we're one step closer to an adaptive, self-improving digital defense ecosystem. Thanks for watching. If you want to see how this technology could protect your data, hit subscribe. And drop a comment below. What's one thing you'd want an AI mentor to teach you? Stay curious, and we'll catch you next time.